Hello, everyone. Today we are going to talk about our economic statistic project. I'm gonna first share with you what I want to you from you guys. So first, I uploaded the college CSV file on Blackboard. Maybe sometime it was last week. So by now you should be able to see this kind of data. Let me show you how the data looks like. Okay, so if you open the file I posted, there are the data is looking like this. So it's in CSV file, and so each of this column is a variable names. For example, this is school name, and this is an indicator whether they are private or not. This is number of applications, number of acceptance, and enrollment, and etc. etc. So what I am interested in is the last column, which is graduate rate. In other words, I'm interested in the 60% of students are graduating. 56 is 56 percent of students are graduating. Some are 100% and 88%, etc. I think I just posted this data set. I mean this no actually this one no, actually, this one. But the definition of a college data set on Blackboard, so you should be able to see what is the meaning of each of them. So the goal of this research paper, I mean, this is not research paper, but some kinds of data analysis experience for you because many of you guys probably have been taking a lot of economic courses or statistic course like that, but you probably have never experienced in what is the actually how you deal with that. I mean, some of you guys might graduate this year or maybe next year like that. So this kind of experience will give you benefit for job market interview or when you are actually working as an analyst or something like that. This would be very helpful. So instead of we having the final exam, we're gonna just have this project to substitute that. So I explain in detail the question of that. This is like a 30% of your grade and due date is November 23rd. So um, you can take a look at this, but I want you guys choose at least three variable. You can choose four or even five to analyze the effect of some variable on graduation rate. So what I mean is, for example, this is our graduate rate. We want to know the association between something and something. This is our dependent variable or our variable of interest. You guys probably don't are not familiar with the dependent variable yet because we're gonna learn those in chapter 12. I'm planning to post those video by this weekend so that you can actually take a look at what is it look like. As you know, chapter 11 and 12 will not be on the exam, so purely chapter 11 and 12 are used for the final project, okay? So for example, I'm just choosing some random thing. Let's say this top 10% is something like, okay, the definition is, okay, percentage of new students from top 10% of high school class. That means they are smarter, right? So let's say if this fraction increase, what do you expect for the graduation rate? Of course we will expect, I mean, it's gonna increase. For example, I mean, take a look at that. This is low 18. So for this dude, this is one of the highest. 83% of students are actually from top 10% of high school. So their graduation rate is 100%. On the other hand, like something like okay, this is only 9%. So let's see, their graduation rate is 69, and etc. etc. So I mean, you can see some kinds of relationship between these two, but I want actually you guys to explore those things and how you can find those associations. So to analyze those, you can use several methods. For example, you can use a scatter plot and see the association between these two. For example, you can choose this variable. I'm gonna just I'm gonna demonstrate this in our program, but I'm just wanna show you it's also possible in Excel. For example, scatter plot is something like that. Okay, so oops, where is it? Okay, so it's over here. So based on that, what do you see? It's basically upward sloping, right? I mean, so this x-axis is our graduation rate. Okay, I should actually put graduation rate on the y-axis because that is how we usually define. Oops. Okay. For some reason it. Okay, got it. Okay, so I'm gonna just choose. Some. Oh, you're supposed to drag everything to get the scatter plot, but I'm gonna just choose something for demonstration. This y-axis would be your graduation rate, right? And your x-axis would be top fraction of top. I mean, no, actually, fraction of top 10%. So what you're gonna see is, oops, oh yeah, over here. So graduation rate. Oh, so you might want to change the title, etc. Say like the association between the scatter plot of between this top 10% and graduation or something like that. You can also put y-axis. For example, if you click this one and add a chart element, and then I think it's a chart title or axis title. Yeah, my Excel is super slow for some reason, but you can put the title over here using axis title and etc. So basically what you can see from this one is, okay, as the top 10%, fraction of top 10% increase, you see the graduation rate increase as well. The scatter plot is explained in detail in chapter 11. I'm gonna post a video by today, so that you guys can see what is the meaning. So for details of information, you should study chapter 11 and 12 for this project. But how you create those variables or how you interpret, I'm also in chapter 11 and 12, but I'm gonna just focus on more technical stuff today. But these are the structure of the data set. So I want actually you guys to explore or learn some kinds of advanced technology here. So for that reason, I want actually you guys to learn how to use, oops, I'm gonna just put it over here. Okay, I'm gonna focus on you guys to use how to use R program, which, many of you probably, I don't know how much of your background you guys have, but learning R program is definitely a plus for you guys, especially if you are interested in going to graduate school or finding a job related to data sets. They might ask you what kind of program skill you have, etc. So for that reason, learning R program is definitely a plus. But for those who don't really want to learn our program, I actually explain some of the instruction how to do same analysis we did in the Excel file as well. So you can do exactly same thing in Excel file, the Excel functions, but I recommend you to use our program for your learning. So in chapter 11 and 12 and other chapters, in the class slides, I explain how to use Excel functions. So you can also use that. But if we need other assistant, you can always Google, right? I mean, there are tons of resources. So actually try to find some answers, by, searching what you want, and an answer from online or other resources might actually give you a good practice as well. But by all means, always reach out to me if you have any question, okay? But today I'm gonna just try to explain as much as possible so that you can start working on your project. So I'm gonna demonstrate those things in our program, but Excel is actually pretty easy. I put those information in chapter 11 and 12, and also throughout all chapters. So chapter slides, so you can explore that if you decide to use Excel files, okay? So again, these were our definitions, okay? And then these are our project. So you got total of 30% of your final grade. Okay, I want you to describe as detailed as possible. If you guys just provide only answer without any description, I cannot give you a good grade. Okay, I want you to interpret. For example, if you are analyst, then your supervisor may ask you something, and you don't just give you the result. They want you to interpret your findings. Okay, as students who are taking economic course, you want to interpret as economically as possible. So think of this as a practice. So these are a list of questions like A. This last question is worth 10% of your grade. That is actually almost half of your midterm grade. So try to write up as detailed as possible, at least 1 or 2 pages, Um, so, okay, what I want you to from here is based on the result, you want to recommend to your student school officers that, okay, based on this result, for example, I see as the fraction of students who are great from, like, I mean, this, as the percentage of new students from top 10% of a high school class increase, then graduation rate increases. So I recommend you to recruit more students, or give more admission or financial aid so that we can attract them to our school so that our graduation rate would be higher, something like that. So those are the examples. So as you can see, there are tons of examples I explore. But I also want you to try to create some variables. For example, this is application and acceptance. So based on these two, what can you do that? Or so you can actually create acceptance rate, right? For example, acceptance rate is a fraction of these two. So that is, I mean, in Excel, for example, I mean, R is also easy, but this is this over this. So this is a fraction of acceptance. So acceptance rate can be calculated using this. This is like acceptance rate, something like that. This is enrollment rate. So I mean, I can also have enrollment rate. So something like 721 divided by actually this one. Oops. This one divided by this one is enrollment rate. So they are 74% of students are accepted, but only 43% are enrolled. So this is enrollment. And and then this is a fraction of fraction of undergraduate part-time. This is a part-time and full-time. So based on that, you can also calculate the fraction of undergraduate they are full-time. For example, our denominator, numerator would be this one divided by summation of this one plus this one would be your basically total undergraduate students, but out of that, the J1 is basically undergraduate. So this is a fraction. In other words, okay, 84% of students are actually full-time, and the other remaining like 60% each is part-time students. So you want to know the association between this one and this one. For example, as a fraction of full-time students increase, of course, the graduation rate will increase as well. So if you recommend to your school officials, then you might say, okay, if we find positive relationship, let's say, then they might say, okay, that as the fraction of the full-time students increase, we see the graduation rate increase. So what should you do? So you might want to give some incentive to the part-time students to transit to full-time so that they can graduate on time. Some of the reason for them to being remaining in part-time would be maybe they don't have enough money to cover tuition or something like that. So they can maybe give loans or some financial aid, etc., etc. So those are some examples, and these are all other variables you can explore. So I just gave you a couple of examples, but try to create some of the variable. And then lastly, and most importantly, try to interpret your result. So in chapter 12, I explain in detail how to interpret those regressions. Also, I will try to post some other resources, how to interpret those, okay? But you should explain your result and show your result and see whether that makes sense. For example, if you see the positive relationship between this fraction of full time, this is a fraction for time, association between fractional over time and then graduation rate, then you might say, okay, it's positive, and does it make sense intuitively? Of course. Then you should explain those. I want you guys to interpret like that. So for that reason, the last part of this one is worth 10% of your grade. So think this is seriously, and in each chapter, each question, I put some numbers, so that is how I'm gonna grade. So try to describe in detail, as detailed as possible. Do not just show your answer. And most importantly, do not copy from your students. I mean, there are tons of variables you can explain. So choose at least 3 or maximum maybe 5. Do not put more than 5, because there are too much. So between 3 and 5. But do not copy your students. I mean, your classmates. I mean, there might be some chance, but I will just be serious about cheating for this project, okay? And do not ask anyone from outside of this class help. If you have any question, just reach out to me, or you can Google if you have any question on how to have a function for regulations, etc. But do not consult with any other people outside of this class. So take a look at these questions in detail. And first question, I say, okay, what is a summary statistic? So you got to explain in detail what is the mean. For example, I said, I just made a number. So if summary statistics show mean graduation rate is 0.8, or in our case, because our numbers are basically this one. So you might want to divide everything by, if let's say you're going to get some average of something like, okay, they have average over here 65, right? So your graduation rate would be 65, or that means actually it's not 65, it's actually 0.65 or 65%. This is actually percentage term, right? So you want to explain something like, okay, our statistic, summary statistics show, about 65% of students are graduating throughout 777 schools. So, but some schools are above or some schools are below, but this is average. More details of this explanation is in chapter 3. So if you're having any question or concern, just go back to that. Okay. So in each question, I just try to put some chapter. This is slide 3 and 5. So make sure you got going back. And I ask you a correlation table, which I'm gonna post the video tonight. So you can see chapter 11, similar things, scatter plot, describe in detail. I want your explanation, not the result. So because I'm gonna show you how you get all the result in our program in detail in a minute. So if we just gonna submit the result, I'm not gonna give you a good grade because I already explained. I want your interpretation. So this one makes sense and explain in detail. Okay. And then do the same thing. These are, I'm gonna briefly explain those. So I'm just giving you all the answers in our program, but I want you to interpret. So think this as a good practice, okay? For later part, when you need to write a research paper or something, this experience would help you a lot, definitely. So, okay, how those who didn't download our program yet, these are in our syllabus. Go here first, download our program first. You need to have our program first to learn the R Studio. So download the R first from here, then download the R Studio from here. So other programs are welcome as well, but I try to give you some instruction in R because R is free. Other programs are quite expensive. So try to download this program first. But again, you can use Excel, but I highly recommend you to explore our program. So I downloaded R, and as you can see, I have R and R Studio. So I'll try to open this R Studio. Okay, and open that. So, okay, so then you're gonna see this kind of thing. So I'm gonna explain in detail. So R script. So first you need to import the data set, right? So first I'm just this double shot means you can write anything. The program doesn't lead this as some kind of program. So you can say, okay, I'm gonna import my data. So say, okay, first you should set WD. That is how you import your path. So my data is actually located in here. So it's just put your path users. It's my full name. Downloads. I think I downloaded over here. So and then type whatever name. So you can type anything. So this is like your name. And then equal lead because our file is a CSV. So the data name was college.csv. But I'm gonna just name your name. You can put your name like a June. It's fine. But I'm gonna just name it as a college because because that is the data. So once you drag and run it, you see the data was imported. The green, this blue light means that means good. But if you see some error, that's gonna be in red. So if you click that, you're gonna see exactly the same thing over here. Okay, so this is how you import the data. So again, your main variable interest would be graduation rate, right? So your that variable of interest. So variable of interest would be equal this one grad rate. That was in the last of this one. So as you can see over here, right? So there are many variables, but you can also create your own variable, which I explained in Excel file. For example, I said private, something like, okay, here, can you see this private, whether the college is private or not? It's a yes or no. Is it data? It's data, but can the program read this? No, because this is a character. So you need to convert this to dummy variable. So how to convert dummy variable, I explained in detail in chapter 5. So if you're having question, go back to that. But I'm gonna say dummy variable is either equal 1 or 0, right? So I'm gonna just create yes equal 1. So this is a tip. So because your data is in college, right? So you first need to say, okay, you want to create the variables. Let's say college. College is your data set, but in the college data set, you want to create the variable. So as you can see, there are the list of variable is coming up. So the how it's working is your data and $sign means in your data sets and there will be a variable. So you put variable over here. So if you want to create a variable, so in the college data set, I want to create variable, say private dummy, dummy indicator. I'm just name it and equal. How do we say that? This is like, okay, some function you need to say it's because IFS. So there is a college variable named private and equal yes. And if yes equals 1 and otherwise equals 0, that means if they are equal yes, then equal 1 and otherwise 0. So drag this and run it. So basically I'm creating, so in the last part, can you see the private dummy I just created? So equal 1 if they are yes and 0 otherwise. So that is how you define this variable. And then you might want to create a new variable, like create new variable like a fraction of full time, which I explained over here, right? In Excel, fraction of full time, but in our program, you can do that like here, like, okay, so in the college data set, I want to create a fraction of full time equal 100% times. You don't actually have to have 100%, but because I'm comparing this to fraction, so percentage, so but it doesn't matter. It doesn't affect your result at all. So the data set I'm interested in was f dot undergrad, right? Because that was a variable name under college. So and then slash, so same thing, exactly same thing as Excel. So college $sign and then part-time undergrad, right? And plus what? College dot oops, the data was actually college. And then full-time undergrad. So that is basically exactly the same thing I did over here, right? So for example, where is it? This one. This one, I just have this function, exactly same thing in our program like this. So let's see, fraction of this. So blue sign means it's good. So we're gonna see those variable in the last. So fraction of full time, like that. Okay, easy, right? So, and then I'm gonna just create. Okay, so similarly, you can create another thing. So you can just say whatever thing you want to create. So the variable you want create equal whatever variable combination, something over something or something times something, whatever thing, as shown in the Excel. So try to do some on your own. And first thing is you want to find the correlation. So I want to show you how to find a correlation. Okay, that is use COR. So COR, so data, so the format is something like that. So find the correlation is something like this. Okay, so type of COR and data source it's our college and variable and then data source. And so basically you are looking for a correlation between these two. So I explained the super detail in our chapter 11. So make sure you are looking at those, how you define correlation, okay? Okay, so, and then similarly, I'm gonna know this one, for example, I wanna know the association between top 10% and graduation rate, which I showed you previously using scatter plot. So boom, it's a 0.49. Okay, so correlation is pretty high, you know. And okay, previously in Excel, I show you how to do that, but in our program, it's quite easy. I mean, first time it's not, so how to find the scatter plot is, okay, scatter plot. So I'm gonna say just plot, and then, okay, college, and dollar sign top 10%, right? Because that is your variable, comma. So this is on your x-axis, and comma is on your y-axis, that is college, dollar sign, graduation rate, that is on your y-axis. But it give you the ledger, but you might want to put something like, okay, I want to title it. So I want to put title college lab, that is X title. As you can see, they explain in detail, so equal whatever thing you want. For example, I want to say this as something like this. I want to put this one as, okay, fraction of new students from top 10%. That is why I want to title for that x-axis, and I want to put y have, that is, oh no, y lab, is your y-axis title. I'm just gonna say this is equal graduation rate. So and you wanna put some like a header title. So I wanna say a title is main equal C, and paste as okay, association between percentage of new students from top 10% of high school class, something I just made up. So, and then, okay, then you might wanna put, okay, paste. And because the reason why I'm doing this is basically sometimes title is so long, so it's gonna cut out. So I'm gonna just write in two things. So, so I'm gonna just keep writing this as N graduation rate. So sometimes the title is so long, it's gonna cut it out. So you might wanna do that. And then I wanna put the association, I mean the correlation. For example, I'm gonna put subtitle equal, okay, the correlation coefficient. This is optional, but I recommend it's uh, something like that, which we just got it from here, right? 0.496. So I'm gonna show them, okay, our title of x-axis and y-axis and our whole title, but it's gonna too long, so I'm gonna put it two-way and subtitle, which show you the correlation, so that this scatter plot will give you a lot of information. So as you can see, this one, So association between fraction of this and is your titer, and you see the scatter plot, and as you can see, subtiter is correlation coefficient, so that, okay, they see the positive correlationship, but on top of that, they might be curious what is a correlation coefficient, but they see from this thing at glance. So this is graduation rate and etc. So this is how it's working. So you should create at least 3 or more the scatter plot that variable of your interest. I'm just giving you one example, but you can change your variable name, right? I mean, I'm just having this one, but you can say this one as a fraction of a full time, for example. Then I mean, the title might be, you need to change, but you see another scatter plot, but you should also change the correlation coefficient, etc. So this is explaining how easy is a piece of cake, not because I'm giving you the answer, right? Just in case if you want to save the figure, what you need to do is before the plot and set your the path, whatever path. Let's say this was my path, so I'm gonna just copy this one, okay? And then next of this path is you should type like a PNG. This is your file name, okay? I want to say just top 10 .png for to show you the example, and then after that just say div off like that. So just drag everything and create like that. So let's see whether the file was created. So yeah, I'm just opening this. This was a file just created from here. Isn't it so beautiful? So I mean, you can just copy this one and drag it to a Word file, for example. I mean, so this is how it's working. So so you can do the similar thing a lot. For example, if I want to, this is a okay. This is this thing, and if I want to drag this one, the PNG file over here, then you're gonna see those things over here, something like that. So yeah, so you can try to modify this a little bit, etc., etc. So okay, so these were the R program. So it was quite easy, right? So next thing I want to show you is doing some kinds of regression. Regression is again in chapter 12. This is chapter 12, 12 material, but I'm gonna explain you. So I'm gonna just delete the path because you might not gonna have the same path as me. Okay, so chapter 12 means, so example of linear regression. So for example, linear regression. So something like, okay, simple code is you first name your regression. You can say whatever thing. You can put your name, but June regression, whatever. But I'm gonna also say linear regression, something like that. Whatever, it doesn't matter. So it's basically LM means it's a linear model, and put this time it's gonna be how it's working is your dependent variable put over here. So for example, it's the dependent variable will be on your college data. So let's say graduation rate, and then I want to interested in the top 10% college and top 10%. If I want to look at these two association, then drag this and boom, this, nothing show up, right? Because you are saving your result over here. So you say summary and parenthesis, put your name over here, then it's gonna give you the result. So it's gonna be, this would be your intercept, and this is the interest you're looking for. This would be your estimate you are looking for. And this is your t-stat we learned before, and p-value. So you should be able to interpret this very well. Okay, so that means interpretation. I'm just gonna explain you one example. Since the p-value is less than some threshold, alpha, say 5% or 1%, even 1%, t-stat is really high. So this result is first of all very significant, and the sign is positive and positive, right? So what you can say is, okay, the effect of, I mean, if as the fraction of top 10% increase by 1%, right? And your graduation will increase 0.48 percentage. So every 1% increase in top 10% will lead to 0.48 increase in graduation rate. That is huge, right? So if they increase those fraction like a 10 more percentage, then graduation rate will increase 4.8 percentage, something like that. So another way of interpret this is, I mean, this is just example, but for every unit, interpret is for every unit. So for one unit, increases of X will lead to some changes lead to increase or decrease. In our case, it's increase of Y by 0.48, something like that. So your interpretation should be for one unit increase in X. In our case, the one unit was a percentage. That's why I say, okay, 1% increase in top 10%, then Y will increase by 0.48 percentage because Y graduation rate is also percentage. So I'm gonna explain more detail in chapter 12. So these are the examples, but let's say you decide to use more variable, then you can say plus, and you say, okay, like college, and I mean, there are tons of variable college, and then say, something like your personal expenditure and then plus whatever, or let's say college, college, something like SF full-time ratio. This is a students of faculty ratio. Of course, if higher means bad, right? So I'm gonna just drag this. Basically, I included 3. For your final project, I want you to include between 3 and 5. Choose your own or create more. So these are our results. So this is a multiple regression. So this is basically positive. Basically, top 10% is positive, still positive, but the personal expenditure is negatively associated with, and then student to faculty ratio is negatively associated with. That makes sense. As the student to faculty ratio increase, that means holding faculty constant. Then as the students increase, then basically there are less of faculty member in the school, then graduation rate would be much lower. I mean, that intuitively makes sense. Explain, interpret those results, okay? So lastly, you want to know whether your model is good or not, right? So you can use, for example, draw like a histogram of your error term, and then using this, for example, QQ plot, but you don't have to know this for now, I mean, at this class, but I'm just giving you for your own understanding. So I'm gonna just give you this code. So drag this one and whatever name you had, for example, over here, put over here, and then drag this and boom, it's gonna histogram. If it looks normal, then your model is good. Another way of doing is QQ plot, do the same thing. If this is linear, as close to the linear, then your model is good. So this doesn't violate. So I'm briefly gonna explain this one later, but for your own information, this is how you do that. And also importantly, another way of saying your model is good is this F statistics, which is, and in the last, if this is significant, that means your model is good. The p-value is less than your threshold, that means your model is good. This is another way of interpreting that. So I'm gonna also put that in our this one, like over here. Okay, and you can also interpret the R-square. I mean, R-square was already given in the model, so try to explain those R-square. So basically, this R-square tell you how much variation of Y can be explained by X's, your independent variables. So dependent variable and independent variable, the terminology will be discussed in chapter 12. So make sure you guys study. So that means 30% of your variation of Y or graduation rate can be explained by these 3 variables. In other words, these 3 variables explain about 31% of your model. So higher means better. but it doesn't always mean it's rule of thumb. But this is supplementary. Higher means good, but it's not decision rule whether this is good or not. Usually, Apple statistic is used. So hope this instruction help you. And if you guys have any question, just let me know. But I'm gonna post this R code in the website so that you can explore that. Okay, and see you guys. Bye.